Rockets have given us access to space, and some of the new rockets in development will be a big improvement. But all rockets have some inherent limitations. Every rocket company and space agency would love to have access to a low Earth orbit refueling depot. This would make existing and future rockets many times more capable than they currently are. SpaceX's Falcon Heavy rocket can carry 64 tons to low Earth orbit, but only 27 tons to geostationary orbit and much less to the Moon or Mars. If it could be refueled, then it could carry the entire 64 tons to the Moon or Mars. A second service everyone in the space industry would love is if they could buy bulk materials in space rather than launching them on rockets. Things like water, prefabricated building materials, 3D printer feed materials, solar panels, etc. Currently, the cost of launching cargo into space is anywhere from $1,400 to over $12,000 per kilogram. We can do it for less than $50, and we can even deliver that cargo to any orbit or directly to the Moon or Mars. A third service of huge value would be a space tug service, something that can grab onto any satellite or spacecraft and move it to any other orbit or location. The orbits of satellites degrade over time, and they eventually fall back to Earth. But a space tug could put a satellite back into its original orbit whenever necessary. Satellites that have completed their missions could also be moved to completely new orbits to gather extra data. People and supplies could also be ferried between Earth orbit and the Moon very simply and cheaply. For example, a single manned or unmanned capsule can be used to continually travel between the International Space Station and the Moon without the need to ever refuel or return to Earth. When one space tug runs out of fuel, a new one takes over. The same system can be used to clean up all large space junk currently in orbit. This includes a large number of old nuclear reactors still orbiting the Earth. While this may be a less profitable service, it is very important for our future. Our single solution will provide all of these services, and at a revolutionary low cost. Our system will not compete with rockets. It will complement them. Rockets will always be needed to carry humans, satellites, and delicate equipment and supplies. These capabilities will revolutionize the space industry. Missions and businesses that are currently impossibly expensive will become feasible and profitable. Not only will existing companies and space agencies be able to take advantage of these services, but many new companies will be started to profit from the new commercial opportunities. We will use a superconducting quenchgun, which is a type of electrically powered coil gun based on NASA designs. Using a gun to launch things into space is not a new idea, and there are several difficulties with it that have been discussed over the years. We have solved all of them, and we will address them in this video. Nobody has built a superconducting quench gun before, although a non-superconducting proof-of-concept model was built and successfully tested in 1985, and quench gun proposals have been published by NASA several times. Building the first working quench gun will undoubtedly uncover some invaluable IP and spin-off applications for multiple other industries. Our system can be built quickly with today's technology and materials, can be built for a reasonable cost, perhaps the cost of just a few rockets, is simple, robust and low risk to operate, is extremely efficient, is modular and scalable, can launch an unlimited total mass per year, has a revolutionary low cost per kilogram to orbit. We believe an ideal investor will be an existing rocket company. SpaceX and Blue Origin's ambitious goals could be realized much faster, cheaper, and more efficiently with the help of this system. They would also gain a huge source of revenue from customers using the system. Any other rocket company or space agency who would like to keep up with the rapid progress of SpaceX should also consider investing. Or any other company or government that would like to quickly become a major player in the new space age and profit from it. The location of the launch facility will be in a remote region of northern Australia. This is close to the equator, providing a slight boost from the Earth's rotation, as well as a low inclination orbit. The remoteness of the area will keep the sonic booms and flight path away from populated areas, and ensure the projectile is in space well before leaving Australian airspace. The highest altitude available in northern Australia is only around 1,000 meters. However, a high-altitude launch is not required. We simply use more energy to counteract the deceleration, and an ablative heat shield to deal with atmospheric heating, which we will discuss later in this video. We will use commercially available gas turbine generators, which can provide hundreds of megawatts of power each, although the initial design only requires a single 10 megawatt generator. This means that we do not need any connection to the electrical grid. We simply use tanker trucks to bring fuel for the generators to the launch facility. Tanker trucks will also bring in the liquid cargoes that our customers want to buy in orbit, such as liquid methane, oxygen, and hydrogen. Our projectiles include a small rocket engine used for orbit insertion and subsequent in-space maneuvers. Our engine uses a premix of ethanol and hydrogen peroxide, which is a liquid at room temperature and is more dense than other rocket fuels, which is important for our system. It is relatively safe and easy to handle, and only requires a very simple and robust engine, ideal for the extreme accelerations it needs to withstand. The initial design has a barrel length of 800 meters. This determines the g-forces experienced as the projectile is accelerated. 800 meters results in an acceleration of almost 6,000 Gs. We can easily design our projectiles to withstand these forces. Mechanical wristwatches can withstand over 5,000 Gs, and smart artillery rounds can withstand over 15,000 Gs. This high acceleration is why we can only send robust cargoes. A coil gun capable of sending humans would need to be over 1,000 kilometers long. Our solution is to simply never send humans or anything fragile. Rockets will still be needed for those things. The inclination of the barrel in the initial design is 3 degrees. A low angle results in much less fuel required in the projectile for orbit insertion, but has the disadvantage of a longer flight path through more atmosphere. 3 degrees is a good compromise. The barrel length and inclination determine the height of the muzzle. An 800-meter barrel at a 3-degree incline results in a height of 42 meters. This is simple and inexpensive to build. For context, that is half the height of the Statue of Liberty or Big Ben. These dimensions can easily be changed for the final design. For example, it may be decided that a much higher acceleration and lower launch angle is easily achievable, which would increase the payload fraction significantly. The barrel contains a vacuum, and the end is covered by a plasma window which stops any air from entering the barrel while still allowing the projectile to easily exit. There is an inner barrel which the projectile travels through, as well as an outer barrel which contains the superconducting coils and associated cooling systems. The inner barrel contains a vacuum to ensure no air resistance is encountered while the projectile is being accelerated. The outer barrel also contains a vacuum to help insulate the cooling systems. Cryogenic fluid is continually cooled and circulated to keep the superconducting coils at the optimum temperature. Any fluid that evaporates is condensed and fed back into the system. None is lost. The best argument against using electrically powered guns to launch things into space is that you need to store an enormous amount of energy and release it all in an instant. Achieving this with capacitors or any other known method would be incredibly expensive, possibly the most expensive part of the entire system. Perhaps the best advantage of a quench gun is that it does not require any energy storage system. The superconducting coils in the barrel can be slowly charged over time and will store that energy until it is required. Also, a quench gun can convert over 90% of the electrical input energy into kinetic energy that accelerates the projectile. This is far better than the 20 to 30% efficiency you could expect from a railgun or conventional coil gun. Once all of the coils have been fully charged, they are disconnected from the generator. Projectiles are filled with fuel and cargo, and then loaded into the system. An automated robotic arm picks up a projectile and places it in a bath of liquid nitrogen. This cools the exterior to increase its electrical conductance, as well as to counteract some of the heating experienced during launch and flight. Once sufficiently cooled, it is loaded into the barrel. To quench a superconducting electromagnet means to stop its superconducting property. The first coil is quenched, which induces a current to flow in the aluminium projectile. This current produces a magnetic field in the projectile, which will persist until after it exits the barrel. The strong magnetic field of the second barrel coil attracts the magnetic field of the projectile. As the projectile reaches the second barrel coil, it induces a current zero by what is called motion-induced commutation. The superconductivity of the second coil is then quenched, so as to prevent current from being re-induced in the barrel coil as the projectile passes through it. This is done automatically by a device that is triggered by the projectile's magnetic field. The important factor is the absence of current at the instance of quench, and therefore the absence of energy dissipation. This process repeats for all of the remaining coils. Each coil accelerates the projectile faster and faster. The projectile is automatically levitated because it is attracted to the center of each coil, so there is zero friction and zero wear. The magnetic forces will naturally rotate the projectile during acceleration. This rotation plus its nose-heavy design will aid in keeping its flight stable. The projectile reaches its maximum velocity of over 9 km per second and exits the barrel through the plasma window. We will use an ablative heat shield with an aerospike design. Ablative materials are designed to burn up during the flight, taking most of the heat away with them. And the aerospike design keeps the shockwave away from the main projectile. In under 1 minute, the atmospheric density is less than 1% of that at sea level. Ablative heat shields are a well-understood technology and have been used on almost all re-entry spacecraft. They are also used on nuclear warheads that experience the same velocity at the same altitude that we are dealing with. As the projectile leaves the atmosphere, a timer triggers the ejection of its nose and tail cones and the extension of its docking pylons. The cones will burn up as they tumble through the atmosphere back towards the Earth. Simple electronic sensors and rotational thrusters are used to cancel out the projectile's rotation. At precisely the correct time, the main thruster ignites and puts the projectile into a stable circular orbit. This is what we call a dumb projectile. It is extremely simple, reliable, cheap, and is mostly cargo. It doesn't contain any computers, just basic electronics. However, every 9th projectile is what we call a smart projectile. These contain computers, communications, navigation, full directional thrusters, and the ability to automatically locate and dock with other projectiles. Having smart and dumb projectiles massively reduces costs and complexity whilst maximizing total payload fraction. Once a smart projectile has docked with all 8 of its dumb companions, it docks with 3 other sets to form what we call an array, which consists of 36 projectiles. With 4 smart projectiles, 1 on each corner, the array has very good orientation and propulsion capabilities. Arrays can continue to dock together to form even bigger arrays, so the system is completely modular and scalable. These arrays will have different missions depending on the mix of contents of the dumb projectiles contained within them, the most basic being a self-contained and maneuverable refueling depot. The rear docking pylons are pipes that are used to share our ethanol hydrogen peroxide fuel. This means that each smart projectile can potentially burn all of the fuel contained in every projectile in the array. The front docking pylons share the liquid cargo, such as a customer's specified type of fuel. So a single refueling nozzle can supply a customer with all of the liquid cargo contained in the entire array. In this scenario, the fuel required for orbit insertion is less than 10% the mass of the projectile. By comparison, rockets are more than 90% fuel. This is what gives our system such a huge advantage. We keep the majority of our system's mass on the ground, while a rocket carries all of its mass up with it. The best payload fraction of any space rocket was the Saturn V, at 4.3% payload. Even new rockets in development cannot do better, although they are reusable. Meanwhile, a Boeing 747 has a payload fraction of around 50%, similar to our projectiles. In rockets, each kilogram of payload requires huge amounts of fuel. For this reason, everything they launch is designed to be as lightweight as possible. This results in very high costs and can lead to lower reliability. Our system is free from this obsession with weight. Our quenchgun can be as big, heavy, and robust as we like because it never has to move. Weight is also much less important in our projectiles. In fact, a heavy projectile actually flies better and more efficiently than a light one. It just requires more energy to launch, which is very easy for us to provide. So our projectiles are designed to be extremely robust and reliable. We can use cheaper materials and off-the-shelf parts without worrying that they weigh more. For example, our heat shields can use simpler and cheaper mass-produced materials. We just use a thicker, heavier layer than would be needed with a high-tech, expensive material. In addition, after delivering their cargo, used projectiles will be recycled and sold as building materials in space. So none of the mass we launch is wasted. It will all be sold. To summarize, our solutions to commonly cited arguments against using coil guns for space launch are as follows. Acceleration G-forces. We only launch robust cargo. Atmospheric heating. We use ablative heat shields and an aerospike design. Energy storage. We store the energy in the superconducting coils of the gun. Orbit insertion. We use ethanol hydrogen peroxide thrusters for orbit insertion. Launch location. Remote Northern Australia. High altitude or equatorial launch are not necessary. High speed, high current switching. The projectile's motion triggers independent electronic devices to quench each coil, and switching only occurs when there is no current. It is often claimed that a coil gun should launch from a mountaintop to avoid the thick atmosphere at sea level. While this would indeed help slightly, it is just not necessary. We can easily provide enough heat shielding and extra velocity to launch from sea level, whereas building on a mountain would be a logistical nightmare, extremely expensive, and very difficult to negotiate politically and environmentally. A huge effort and expense for a very small saving that we just don't need. People often assume that a large launch angle of up to 45 degrees up the side of a mountain, or even vertically, would be good. This is not true, as the projectile would need much more fuel for orbit insertion, which makes the payload fraction much smaller. 10 degrees is about the maximum angle you would want. Another claim is that the location should be on the equator to take advantage of the Earth's rotation. This bonus velocity is actually only 5% of the total velocity we need to fire at. Coil guns are inherently scalable. You can fire any size and mass projectile at any velocity with any acceleration you want just by scaling the coil gun to fit your goal. We have chosen the current system specifications for what we believe is a good balance for a realistic system that could be built today with minimal cost and development that will result in a revolutionary cost per kilogram and total payload per year. However, it could easily be scaled down to lower the cost dramatically, or scaled up to increase the efficiency. Also, once the system is built, it can be scaled up by simply adding more generators. The initial system will fire a projectile every 90 minutes. This will put them all in a single orbital location to enable them to easily dock with each other. But by adding another generator, we can recharge the coils twice as fast, so we can fire every 45 minutes into 2 different orbit locations and build 2 separate arrays, doubling our capacity without any changes to the quench gun or projectiles. We can add more and more generators, the only limit being how fast we can physically load the projectiles into the barrel. The initial design stated here firing once every 90 minutes will result in a total payload to orbit of over 1,300 tons per year. If we added 3 570 megawatt generators, the same gun, using the same projectiles, could fire every 14 seconds and launch over 500,000 tons of payload per year. If you want more than that, you can build more barrels as well as bigger projectiles. There really is no limit to how much you can launch. SpaceX's upcoming Starship will be the most capable spacecraft ever built, but even it will benefit enormously from our system. A Starship could be refueled by a single array, rather than requiring 4 or more tanker launches. Benefits would include faster and simpler refuelling, no need to wait for multiple tanker launch windows, risk reduction with only one booster launch and one docking maneuver required. Less booster launches. Use their lifespan on important cargoes rather than fuel. Fewer or none tanker spacecraft need to be built, so more crew and cargo versions can be built instead. Additionally, after refueling, another large array could dock with and push the Starship to give it a head start towards Mars. This would enable the Starship to reach a much higher top speed, significantly reducing the transit time to Mars. To summarize, we have a realistic, low-cost plan that uses existing technology and materials to provide multiple services of huge value to existing cash-rich customers. We will revolutionize the space industry, creating a new market, generating huge profits, and providing calculable political power and prestige to the countries that back us. The limited R&D that is required will undoubtedly result in valuable IP and applications for multiple other industries. Bear in mind that the same concept can fire anything from a few milligrams to many tons at any velocity, optionally with a very high rate of fire, all with no need for an energy storage system. Our single solution provides 4 valuable services: low Earth orbit refueling depot, bulk material supplies, space tug service, space junk cleanup, and it features revolutionary low cost per kilogram, unlimited mass launched per year, scalable in multiple ways, will multiply the capability of existing and new rockets. Please visit our website for citations, documentation, and to contact us.